Last Good morning, children. Last class we have seen about extraction of metals, that how to concentrate the metal ore by calcination and roasting process we have learned, isn't it? So this class continuation of extraction of metals we can see. So third step is reduction. So what is meant by reduction? Heating of oxides of metals to turn them into metal is known as reduction. So we should concentrate the ore, then we have converted the ore into the oxides of metal, isn't it? Now how we can turn the oxides of metals into metal? By the process called reduction. Okay, so here we have to heat oxides of metals to turn them into metal. This process is known as reduction. Now during reduction, the extraction of metal, the less reactivity metals and medium reactivity metal, high reactive metal is different. Okay, so first we are going to see about extraction of metals of least reactivity. So example for the metals belonging to the least reactivity series is mercury and copper. Okay, so this mercury and copper, they found in the form of their sulfide ores. So the ore of mercury is cinnabar. Okay, so what is the ore of mercury? Cinnabar. It is also called as mercury sulfide. Okay, so Hg means mercury sulfide, HgS. So cinnabar is the ore of mercury. And copper glans or Cu2S, copper sulfide, is the ore of copper. Okay, now let us see how these ore, that is the ore of mercury and ore of copper, get converted into their metal form. First we will see about extraction of mercury metal. So we know cinnabar is the ore of mercury, isn't it? So first cinnabar is first heated in the presence of air. This turns mercury sulfide or cinnabar into mercury oxide by liberation of sulfur dioxide. Okay, so this is the roasting process. Yes, so we will heat the ore of metal in the presence of air. Last class we have seen what is meant by roasting. Heating the ore of metal in the presence of air, it will release sulfur dioxide gas, isn't it? So here first step is mercury sulfide is turned into mercuric oxide by liberation of sulfur dioxide when we are heating mercury sulfide in the presence of air. Now this mercury oxide is again heated strongly. So when we are heating strongly this mercury oxide, it reduces into mercury metal. Okay, so when we are strongly heating mercury oxide, it gets converted into mercury metal. So here is the equation which reaction which take place during this reduction process. Okay, so first we are heating mercury sulfide in the presence of oxygen so that it gets converted into mercury oxide, that is HgO, plus with the liberation of sulfur dioxide. And once this mercury oxide heated very strongly, it reduced to mercury metal plus oxygen. Now another example is extraction of copper metal. So the ore of copper is called as copper glance, isn't it? Cu2, yes, that is copper sulfide. So it is roasted in the presence of air. As they are in the form of sulfide ore, they undergoing roasting process to be converted into their copper oxide or their metal oxide. Okay, so here copper glance is roasted in the presence of air. Roasting turns copper glance into copper oxide. Then copper oxide is heated in the absence of air. Okay. So this reduces copper oxide into copper metal. Okay. So first we have to roast the copper glance in the presence of air. The time it will get converted into copper oxide, and once it gets converted into copper oxide, we have to heat it in the absence of air. This reduces copper oxide into copper metal. Understood, children? Now here you can see the equation form, the reaction which take place during extraction of copper metal. So copper glance or copper sulfide Cu2s in the presence of air, it is converted into copper oxide plus sulfur dioxide. Again, when we are heating the copper oxide in the absence of air, it gets converted into copper plus sulfur dioxide. So from there the copper metal can be extracted. Now second is the extraction of metals of middle reactivity. So example for the metals which is medium reactive metals are iron, zinc, lead are found in the form of carbonate or sulfide ore. So these medium reactive metals such as iron, zinc, lead are found in the form of carbonate or sulfide ores. So here also same thing. If it is in the form of carbonate or sulfide ore, first it's get converted into their metal oxides. Then the oxides are reduced to respective metals. Here we can see example. First extraction of zinc. So zinc blende or zinc sulfide is the ore of zinc, and one more ore of zinc is smithsonite or zinc spar. It is also called as calamine. It is also called as zinc carbonate. Okay, so zinc blende is also known as what? Zinc sulfide. Then smithsonite or zinc spar or calamines, it is also called as zinc carbonate. Okay, so this zinc blende and zinc spar are the ores of zinc. First, this zinc blende, which is in the form of sulfide ore, is roasted to be converted into zinc oxide. We know if it is in the form of sulfide ore, we will undergo which process? Roasting process, isn't it? First video we have seen. So in the same way, zinc blende, it is in the form of sulfide ore. It is roasted to be converted into zinc oxide. Then zinc spar, it is in the form of what? Carbonate. Yes, so it is put under calcination process to be converted into zinc oxide. So here is the reaction which take place during zinc sulfide. So zinc sulfide plus oxygen in the presence of air, it converted into zinc oxide plus sulfur dioxide. Then zinc carbonate undergone calcination process, that is it is heated in the absence of air, gets converted into zinc oxide plus carbon dioxide. So, zinc oxide which is obtained is then reduced to zinc metal by heating with carbon. Okay, so once we got metal oxide, that is zinc oxide, it can be reduced to zinc metal by heating with a reducing agent such as carbon. Okay, so carbon is a reducing agent which will convert the zinc oxide to zinc metal. Here is the reaction which take place during the conversion of zinc oxide to zinc. So zinc oxide react with carbon and form zinc plus carbon monoxide. Now extraction of iron from chamatite. So chamatite is the ore which is occur in the form of carbon. Chamatite is the ore of the iron which is reduced to iron metal by heating it with the reducing agent such as carbon. So we know carbon is the reducing agent. Yes, here iron oxide, when we are heating it with the carbon, it gets converted into iron plus carbon dioxide. Now, next example of the extraction of metals which is medium reactive is extraction of lead from lead oxide. So lead oxide is also heated by using reducing agents such as carbon and reduced to lead metal. Okay, so here carbon is acting as a reducing agent and reducing the metal oxide or lead oxide into metal or lead plus carbon dioxide. Understood, children? So lead oxide is heated with carbon to be reduced to lead metal. Now reduction of metal oxide by heating with aluminium. Okay, so first we have seen that carbon is the reducing agent. So the metal oxides are converted into metal by using a reducing agent such as carbon. Yes, now we are going to see reduction of metal oxide by heating with aluminium. Okay, so aluminium is also one more example for reducing agent. So when metal oxides are heated with aluminium, it gets converted, it is reduced to metal oxide is reduced to metal. So manganese dioxide and copper oxide are the metal oxides which are reduced to respective metals when heated with aluminium. So example for the metal oxide which is converted into its metal by using aluminium as a reducing agent is manganese dioxide and copper oxide. So these are metal oxides which get reduced to its respective metal when heated with aluminium. Here is the reaction which take place during the reduction process. Here manganese dioxide react with the reducing agent such as aluminium and gets converted into its metal called manganese plus aluminium oxide. Then copper oxide, it react with the reducing agent such as aluminium and gets converted into copper plus aluminium oxide plus heat. Now next one type of chemical reaction, that is thermite reaction. So what is mean by thermite reaction? Ferric oxide when heated with a reduced agent such as aluminium, it gets reduced to iron metal. Okay, so ferric is the form of iron. Yes, so ferric oxide when heated with aluminium, it is reduced to iron metal. Such a reaction is called thermite reaction. in this reaction, why this reaction is called as thermite reaction? Because during this reaction, a lot of heat is produced. Okay, so thermal means what? Heat, isn't it? So thermite means when the ferric oxide is heated with reducing agents such as aluminium, it gets reduced to iron metal with a liberation of lot of heat. Okay, so this reaction, lot of heat is produced, so this reaction is called as thermite reaction. So the thermite reaction is used in the welding of electric conductors, iron joints, etc. Okay, so this thermite reaction is used in the welding of electric conductors, iron joints, etc. So iron joints, example, joints in railway tracks. You know, railway tracks is made up of iron metal. Yes. So while joining the railway tracks, they will use this thermite reaction. Okay, so this thermite reaction is also known as thermite welding. Okay, so the welding of the welding done by using the thermite reaction is also known as thermite welding. Okay, so thermite welding means what? The welding process done by using thermite reaction is known as thermite welding. Now here is the reaction which take place during thermite reaction. So this thermite reaction is very important question, children, 3 mark question. Okay, so here iron oxide gets converted into iron by the reducing agent called aluminium. So iron oxide is reduced to iron plus aluminium oxide with the liberation of lot of heat. Now third step, extraction of metals of high reactivity. So we have studied extraction of metals of least reactivity, medium reactivity. So last part is extraction of metals of high reactivity. So metals of high reactivity, example, sodium, calcium, magnesium, aluminium are extracted from their ore by the process called electrolytic reduction. Okay, so these metals cannot be reduced by using reducing agents such as carbon, because carbon is less reactive than these high reactive metals. Okay, so these metals are highly reactive than carbon, so it cannot be reduced by the help of carbon. Okay, so that we are using the process called electrolytic reduction for reducing the metals of high reactivity. Okay, so what is meant by electrolytic reduction? So in this process, electric current is passed through the molten state of metal ores. Okay, molten state means, you know, metal start to melt. That state is called molten state. Yes, so electric current is passed through the molten state of metal ore. Metal, as they are positively charged. In previous class we have seen metals forms positive ions. They have positive charge ions. Yes, so as they are having positively charged ions, they will deposit over the cathode. Okay, so metals being positively charged, they will deposit over the cathode. So example is when an electric current is passed through molten state of solution of sodium chloride. So now we have taken the highly reactive metal, that is sodium. When electric current is passed through the molten state of solution of sodium chloride, sodium metals get deposited over the cathode. Okay, so here is the reaction. sodium chloride. Okay, sodium, as they are having the, is a metal which is having the positive charge ion, they gets deposit over the cathode. So metals obtained by the process of electrolytic reduction are pure in form. Okay, they will not be having any impurities. Okay, so they don't want to be refined. Okay, so the metal obtained by the process of electrolytic reductions are pure in form. So I hope you have understand about the reduction process of highly reactivity metals, medium reactivity metals and least reactive metals. Children, if you have any doubt, you can ask. Thank you.